All right, welcome back to day 7, boys and girls, and today we're discussing circles. Hopefully you've been checking out the videos regarding geometry, and we did lines and angles, we did polygons, we did triangles, and now we are come to circles. So, a few things before we start solving problems. I don't want to get into what tangent, well actually I do want to say what tangent is. Tangent is a line that touches the circle from outside, and the main thing we need to know is the radius to the tangent is always creates 90-degree angle. That's very key, and we're going to use that a lot. The measure of semicircle is 180 degrees. The measure arc is 360 minus the measure of minor arc. So there's a major arc and minor arc. Major is the whatever left. So they're complementary, meaning they add up to 360 degrees. What else do we need to know here? This one is simple. Tangent lines. If a tangent line to a circle, if a line is a tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So that's what I just talked about. If we have tangents, doesn't matter where, that tangent will always create a 90-degree angle with the radius. The another key point here to remember is that tangents to a circle from a same exterior point, so it doesn't matter which one you're using, in this case it's P, it could be here, tangent, okay, that cut the line, tangent, which is touching, imagine this touching here, imagine this touching here, so these also have same distance. So if this is X, this is also going to be X. Okay? So, let's solve some problems, shall we? In the figure above, BD is a diameter, and PA and PD are tangents to the circle. CD is 52, APD is 45, AP is... I know there's a lot of stuff going on here, but that's because we have 4 different questions. So let's start from the first one. What is the measure of ODC? Now, ODC is this angle right here. So, again, we just learned that if you have a tangent line, which PE is a tangent line, or PD, doesn't matter, then the radius to the tangent creates a 90-degree angle. So this part is 90, and so is this one, right? So if that's 90, this one is 52, it's given, then the remaining part will be what? 90 minus 52. So angle ODC is going to be equal to 90 minus angle, well, I'll just say 52. 52, and that's going to be equal to 38 degrees. What is the measure of OCD? Before they asked for ODC, now OCD. So let me get rid of some of this stuff, and OCD, where is OCD? OCD is right here. So what do we know about OCD triangle? We know that OD is a radius, we know that OC is a radius, so this is an equilateral triangle. So that means the angle to the bases should be the same. So this angle right here should be equal to this angle. We already know ODC, which is 38, and this angle is going to be equal to that. So angle OCD is equal to angle ODC, and that's also going to be equal to 38. What is the measure of AOD? AOD. Where is AOD? AOD is this angle right here. So, we know tangents create 90 degrees, so there's 90 here, there's 90 here. This is a 4-sided polygon, so we know internal angles should be equal to 360, or we know the angles that opposing each other should be adding up to 180 degrees. Let me erase this. So this one and 45 should add up to 180 degrees. So angle O plus 45 should be adding up to 180 degrees. That means angle O is going to be 135. What is the length of PD? Now the length of PD is going to be equal to length of PA. Why? That's equal to 9. Why? Again, because we said any tangents from external point to the circle has the same length. All right, moving on. Circumference of a circle is 2 pi r, or pi d. We don't need to talk about that. Area is pi r square. Now, the main thing to remember here is sector of a circle. The length of the sector is with the formula here, and the area of the sector is with the formula here. The distance traveled by a wheel equal to 2 pi r times the number of revolution. That's basically when you make rounds around the circle. So you'll take 2 pi r, which is your circumference, times how many circles you made around your shape, and that will give you the total distance traveled. You can think of it as traveling around the world, right? So let's see if we can solve some problems regarding to this stuff. In the figure above, the radius of a circle is 8, which means this one is also going to be 8. I'd like to start writing things as soon as they are apparent to me. And AOB is 120 degrees, so this is 120 degrees. Now, again, I'm not reading the rest of the question just yet. I know that AO and OB are both radius, which means they will be equal to each other, right? That's why they're both 8, which means it's an equilateral triangle. So triangle AOB is equilateral, which means angle A should be equal to angle B. And if this is 120, the rest is going to be 60 divided by 2. So 30 for each. What is the length of AB? Now, to find the length of AB, I can use multiple things, but the simplest one and the one that we actually know is going to approach it like this. So I'm going to isolate the triangle. This is my A, B, and O. Now, I'm going to drop a height here because we're going to need that. Let me try to do... Okay, imagine that's a height. This is 90 degrees. So I know this part is 30. I know this part is 60. So this is a 30, 60, 90 degree triangle. Okay, this part is 8, which means the side that's in front of the 30 is going to be 4. The other one is going to be 4 square root of 3. If you're not sure why, check out my video about triangles. That's where I talk about 45, 45, 90 and 30, 60, 90 triangle. So this is going to be 4 square root of 3. So is this one. So the answer is going to be 8 square root of 3 for the whole length of AB. In the figure above, OP equal to OQ. Again, the sides are equal, which means this is an equilateral triangle. Right? So this is 30. That means this is also going to be 30, which also means this is going to be 120. I might not need it, but I just like doing it. Also, I like doing it so that students can get used to the fact that there's a lot of information usually in geometry you can find with the given, whatever is given to you. So PQ is a tangent to the circle, again, which means there it's touching. Again, why they are saying tangent? Because if you drop a radius, that's going to create a 90 degree angle. If the radius of a circle O is 8, radius is 8. Oh, sorry, the radius of the circle, yes, it is. This is 8, this is 8. What is the length of QR? Okay, again, let's isolate the triangle, just so we can draw it bigger. P, O, Q. I imagine that's height. So this part is 30. That means this is 60 because this one is 90, right? So we know this part is 8. How do we know? Because it says the radius is 8. If this is 8, this is the side in front of 30 degrees, which means the hypotenuse is going to be 16, and this one is going to be 6 square root of 3. The question says, what's the length of QR? QR, what's QR? QR is the distance, R is somewhere here, is this distance, okay? Now, I didn't even need to find this side, 8 square root of 3. I know that my radius is 8, so OR is 8, and OQ is 16, which means QR is going to be equal to OQ, which is 16, minus OR, which is radius, and that's going to be 16 minus 8, and that's going to be 8. All right, moving on, another important topic. Inscribed angle is an angle whose vertex is on a circle and whose sides are containing chords of the circle. Now, the main thing we need to remember in this type of questions is this angle here, if they are touching to the same point, is 2 times this angle. So angle B is equal to 1/2 of angle O. Okay, that's very, very important. And also, this AC, which is a sector or arc, this arc has a degree, for example, 60. Then angle O is going to be 60 degrees. I just got off the screen. Angle O is going to be 60 degrees. And what else? And angle B is going to be half of that, which is 30. Okay, very, very, very important. Let's read these corollaries. 2 inscribed angles that intercept the same arc are concurrent. So because they're looking at the same arc, the angles will both be the same. The angle inscribed in a semicircle is a right angle. Now the reason for that is this is 180 degrees semicircle, right? So half of that is going to be 90 degrees. If a quadrilateral is inscribed in a circle, its opposite angles are supplementary. So meaning these are going to be supplementary, which is in the circle O above, AB is a diameter. What is the value of Y? What's the value of Y? Where is Y? Y is right here. Now, if you remember what we just talked about, this angle will be similar, or well, not similar, same to the arc angle. So DB arc is equal to 48. So angle Y is also going to be 48. Very simple, just rules. What is the value of X? Now, X is going to be, again, based on this rule that we just talked about, half of DB or half of Y, which is 24. What is the value of W? Now, where is W? W is right here. It's looking at AB. And they gave us a hint. AB is a diameter, which means this whole piece, this whole arc, is 180 degrees. Semicircle. Okay? So half of that is going to be 90. So W is equal to 90. Last one. What is the value of Z? Now, where is Z? Z is here, CD. If you look at arc AB, that's equal to AC plus CD plus DB, right? Now, what's AC? AC is 100. CD is Z, we don't know. And DB is 48. And they should add up to 180 degrees. Why? Because AB is a diameter, meaning AB arc is 180 degrees. So whatever the solution to that is, I think it's 32, is going to be our answer. All right, moving on. Couple more theorems. If in the same circle or in concurrent circles, concurrent arcs have the same concurrent chords. So if AB is similar to CD, then AB is equal to CD. Okay? If AB as a chord equals to this chord, that means, sorry, not chord, the angle, that means that, all right, a couple more theorems here. If the arcs are the same, if the AB is equal to CD, arc angle-wise, then their chords should also be equal to each other. If a diameter is perpendicular to a chord, it bisects the chord and its arc. Meaning, if this part, if AB is equal to 8, then AE is going to be equal to EB, and that's going to be 4. And same goes for the angle AC. If the AB arc is, I don't know, 60 degrees, then AC is going to be 30, this is going to be 30. And the last one, in the same circle or concurrent circles, chords equidistant to the center are concurrent. So if OF is equal to OE, equal distance, then the chords are same. Okay? Now, these are just rules we have to remember. There's no way around them. And they help us quite a lot to solve some problems. So let's see. In a circle O above, if the radius is 13, PR is 24, what is the length of QS? So radius is 13. So OQ is a radius, and that's equal to 13. PR is 24, that's okay. And what's the length of QS? QS. Now, to find QS, we need to subtract OS from the radius. So this part is the radius. This part is what we're looking for. So we need to find what OS is and subtract it from the radius. Okay? Now, these two, we just talked about if diameter is, sorry, if radius is a well, actually we said diameter is perpendicular to the chord. That means it will split it into half. So I know it's not diameter, but we can extend it. It can become a diameter, so that's not the point. So if we divide it into 2, this is going to be 12. This is also going to be 12. Now, what does that give us, you might ask? We can complete it into a triangle, which is usually the case with these type of questions. So we know this is 12. We know this is 13. How do we know? Because this is a radius. So we have a triangle, a right angle triangle, which has 13 hypotenuse. One side is 12. What will be the other side? Pythagorean theorem, 13 square is equal to x squared plus 12 square. And this is going to be 25 equal to x squared. And x is going to be equal to 5. So this part is 5. Now what is 5? OS is 5. So QS is going to be OQ, which is radius, minus 5, and that's going to be 8. Okay, now this might confuse you because we just saw a similar theorem, but this is not according to the theorem. Why is that? In a circle above, if RS is 6, OM is 5, and ON is 4, what's the length of PQ? So that theorem we talked about was for the case where OM is equal to ON, but it's not in our case. So OM is 5, ON is 4. What is the length of PQ? PQ, okay. Again, always in these questions you can start thinking in terms of a triangle, right? And then things will get easier. What do we know? We know RS is 6, which means each of these sides is going to be 3. What else do we know? OM is 5. Okay, actually let me do it here. So I've got a triangle. This is 3. OM is 5, right? So we can find OS, which is our radius. This is going to be square root of 5 squared plus 3 squared, which is 25 plus 9, 34. Okay, not a nice number, but let's leave it for now. What is the length of PQ? We're looking for PQ. We know this one already is square root of 34. We know ON is 4. That means we can find NQ, or QN, is going to be equal to 30, again, Pythagorean theorem, minus 4 squared, 16. That's going to be equal to 18, QN squared. So QN is going to be equal to square root of 18, which is 3 square root of 2. So PQ is going to be 2 times QW, right? And because PN is equal to NQ, because of the bisection rule that we talked about. So 2 times square root of 3 over 2, 2 times 3 square root of 2, that's going to be 6 square root of 2. So the answer is going to be C. All right, last thing I want to talk about is the equation of the circle. If we have HK as the center of the circle, then we can write this equation of a circle in this shape: x minus h squared, y minus k squared equal to r squared. Now there's a lot of questions regarding this one, but I think I have 2 of them for you to solve. Make sure you pause the video if you want to solve them yourself. The equation of a circle in the xy plane is shown above. Which of the following is true about the circle? Now, when it comes to circle equations, you always have to bring it into this shape before you make any decisions, usually. Okay, now it's definitely not in that shape, but we can bring it to that. If you remember your quadratics, we can complete squares here. So what can we do? We can rewrite this. Let's get rid of 0. X squared plus 12x plus 36, y squared minus 4y, and I think plus 4, right? So this can become x plus 6 squared. This can become y minus 2 squared. But we need to make sure that 15 is not lost in this process. So these two add up to 40. To get 15, I need to subtract 25. Okay, so this equation is going... Oh, I just noticed that I just went off the screen here. Minus 25. So I'm going to take this equation here and write x plus 6 squared plus y minus 2 squared, right, equals to 25, which means my h and k, so the center of the circle is negative 2 and 2, oh, sorry, negative 6 and 2, and the radius is equal to square root of 25, which is, let me write it down here. So r is equal to square root of 25, which is going to be just 5. Okay, so the answer is going to be negative 6, 2, and radius is 5. All right, last question of this video. Which of the following represents an equation of a circle whose diameter has endpoints at negative 6, 4, and 2 and negative 6? Now, seems tricky, but check it out. Imagine this. Negative 8, 4 is roughly negative 8, 4, let's say somewhere here. And 2 and negative 6 is somewhere here. Okay, so imagine, I don't know if I'll be able to draw a circle, but I tried. Imagine this is your circle. This is your diameter, right? So the center is somewhere here. We don't know what center is, but we do know the endpoints. 2 and negative 6. Now, to find the center, what do we need to do? We need to find the midpoint of these 2 points. Why? Because the center of the circle is equal distance from, in terms of diameter, right? It's right in the middle. So how can I find the midpoint? Very simple. I can say negative for x point, negative 8 plus 2 divided by 2. That's going to be negative 4. For y point, 4 plus negative 6 divided by 2, that's going to be negative 1. So negative 4 and negative 1. Negative 1. Did I do that wrong? Yes, I did do that wrong. Because this 8 minus 2 is 6. 6 divided, this is 3. So negative 3 and 1. This should be negative 3. Negative 3. And what's the radius? Well, we can find the radius based on, we can find a radius like that. There's a couple ways actually we can do it. We can do the distance formula between 2 points, or we can use a right angle triangle. So I'm going to isolate that. Now this is negative 3. This part is negative 8. So distance is equal to how much? Let me move that up a little. So the distance is equal to 5, negative 3 and negative 8. What about top? So 1 is here, and there's 4 here. This means this one is 5. So 5, 5. The hypotenuse is going to be 5 square root of 2. which means my radius is 5 square root of 2. So my equation should come to, final line, is going to be x plus 3 square plus y plus 1 square equals to 5 square root of 2 square, which is equal to 50? Yes, so the answer is going to be B. All right, I think that concludes this video. Thank you for tuning in. Hopefully you learned something. There will be another video in geometry section, I think, which is going to cover surface areas and volumes. Make sure you check that out. If you have any questions, please feel free to comment below. And if you want to see certain questions or certain topics before your September 13 SAT exam, let me know and I'll do my best to cover it. Until next time, take care of yourself.